All right, so we're just continuing the lesson on our solution stoichiometry. So just for the purpose of the recording, I just want to recap here what we saw. So we saw that we're dealing with calculations in solution now. We're doing solution stoichiometry, and there's three main types: ion dissociation, the concentration to mass, to volume, to mole, or to other concentration type problems, and then limiting reactant problems. We saw that the first important skill you need to have is being able to write a dissociation equation. So we have, for example, calcium chloride. When you throw it in water, if it dissolves, it becomes aqueous. But we want to represent that as the ions. So we put calcium plus 2 and then chloride minus 1. And those are just charges from the periodic table, or if you have polyatomic ions, it's from your polyatomic ion charges. We have to make sure we put AQ because that indicates it's dissolved in water. And the mole ratios apply in much the same way they would in any really chemical reaction. So for example, we have a 1-to-1 ratio over here, and then a 1-to-2 ratio over here. So you have 2 moles of chloride for every 1 mole of calcium, 2 plus, for every 1 mole of calcium chloride. And so in this first question here, what we did is we had 25.5 grams of aluminum sulfate. We threw it in water and dissolved it, and basically the solution was about 500 mils of solution. Okay, so the entire volume is 500 mils. Our first step was to write out a dissociation equation. So we wrote down our aluminum sulfate as a solid, made an arrow to indicate we're going to dissolve it in water. And we just separated it into the ions and balanced it with the proper coefficients. So then what we did is wrote everything down. So we put the concentration, that's what we're looking for the sulfate ions. We have our volume provided to us, which is the 500 mils. And then we also have our aluminum sulfate. We had the mass given to us. And we decided to find the molar mass because we thought, you know what? We need moles of the sulfate to finish up this problem. So if we find the molar mass of the aluminum sulfate and find the moles of aluminum sulfate, we can then do a mole ratio to find the moles of sulfate. And that's what we're doing. So we found the moles of aluminum sulfate over here. And so we are going to go ahead and find our mole ratio now, and then use that to find the moles of sulfate. So what would our mole ratio between the aluminum sulfate and sulfate be? Right, it's a 1-to-3 ratio. So let's make this, so finding the mole ratio and finding the moles of sulfate, step 2. So we have 1 aluminum sulfates for every 3 sulfate ion. And so now we can go ahead and use our mole ratio to do that. So we have 0.0745 moles of aluminum sulfate multiplied by, now keep in mind, there's more digits there. They're just in my calculator. I don't want to write them all down. Multiplied by 1 mole. Whoops, not 1 mole. Wrong way for the ratio. We want to do 3 moles of sulfate for every 1 mole of aluminum sulfate. Basically, we're just multiplying by 3 because it's a 1-to-3 ratio. So cross that out, and we get our number of moles, so times 3, and we get 0.223573077 moles of the sulfate ion. So we do want to keep. Do you mean when you write out the, like in step number 1, the full chemical reaction, the full chemical equation? Oh, yeah. So over here, so technically it doesn't really matter if you don't put it there, but just to be consistent, keep the charge there. It's not going to affect your math really, as long as it's okay in the equation. Like if you have it written down properly in the equation, you're fine. So it won't have any negative repercussions on you unless you keep writing it like that. I would just, for the sake of getting into the habit of writing charges, just keep it in there, and just know that it's a charge of that ion. Yeah. So now we have our moles. So we can do our last step here, which is basically just taking our formula C is equal to N over V and just doing it. So let's go ahead and do that. So 0.2235777 moles over 0.5 liters. I get 0.447146155 moles per liter. But I'm not really done yet. What's my last step here? Right, the number of sig figs, exactly. So it looks like that's right, 1 sig fig here, exactly. So we'll have to round this to about 0.4 moles per liter or molar. So that would be the concentration of the sulfate ions in there. 0.4 moles per liter or molar. Are there any questions about that one right now? Yes, good point to bring up. So in a question like this, you could have actually just found the concentration of the Al2SO4 first and then multiplied by the mole ratio right off the bat. So you could have done that. It works for these type of questions because your volume is not changing. Your volume is only 500. Because you're not mixing anything, you can do a mole ratio with the concentration. And I'll actually show you an example like that in one of the examples coming up. So you could have just done like your moles divided by your volume of aluminum sulfate, then done times 3, and then you would have had your answer in the end there as well. So a little bit less legwork in that sense. It becomes a little bit less work, especially if you have several ion concentrations that you have to find. All right. So